to talk a little bit about the investigative task that you have due on Friday. Okay? So let's take a second and let's talk a little bit about that investigative task. You should all have gotten that last week, and if you remember, I did ask that you go ahead and begin. I've had a couple of people asking me questions specifically about this task. It is due on Friday. You're not going to have a whole lot more homework other than to work on that this week because it does take a little bit of time. Okay? So far, you have 4 things for data sets. And I even believe they're called data sets A, B, C, and D. Do you agree? Okay. So here's what you're going to need to do. I would like, if you would, to have 4 different pieces of graph paper. And you're going to have, graph paper usually comes double-sided, so you can do some on the front, some on the back. Just make sure that whatever pen you use doesn't bleed through because you will be using both sides, okay? And you're going to treat each of the data sets individually. And you're going to treat them all individually. So you're each going to have a separate page for graph, all of data set A, all of data set B, all of data set C, etc. On each of these, what you should be able to do thus far is you should be able to create a scatter plot. And I'm just going to write a little arrow here because you're going to do one for each of the data sets. Okay, so on a separate sheet of paper, you're just going to graph the scatter plot of data sets A, B, C, and D. Now, there's no context here. Okay, so we don't have any, we're not labeling axes or anything like that. Obviously, you're going to title them data sets A, B, C, and D. But you're just going to create a scatter plot, and that's something you could have done already so far. Okay? The other thing you're going to do is you're going to write an equation of best fit. And I believe that I called it the LSRL, which just stands for the least squared regression line. It's just the y hat equation. And you're going to do that for each of the data sets as well. Okay? All stuff you know how to do. Now, on the LSRL, or the least squared regression line, your y hat, you are going to use the formulas. Just like you did on your Monopoly, or you should have done on your Monopoly assignment, what you did on the quiz, etc. So you're going to use that B1 equals R times Sy over Sx. You're going to use that B naught equals, and you're going to find the equations using the formulas. And you're going to show me that work. Okay? So all of this you should be able to do up to this point. Nothing new. You're also actually going to state the correlation for each. Okay? So you're going to tell me what the correlation is for each of these. And that can be found using the calculator. Okay, that's okay. You don't have to use a formula for that. But go ahead and tell me what the correlation is. You should find that the correlation is about the same for each of them. Okay, it should be pretty high for all of them. The things that we don't know how to do yet, and we're going to start the conversation today, is called, you're going to calculate each of the residuals. And we're going to talk about what that means today. So this is new, and you're going to actually create a residual plot. Again, these are the 2 new things that you don't know how to do yet that we're going to start the conversation today. Okay? So after today, you should be able to go home and calculate the residuals for each of these, the individual residuals. I'm going to show you how to do that today, talk about what a residual is. And then if we have time, I doubt we will today, but if we will definitely finish it on Wednesday, so you'll have residual plots to create for each of these data sets as well. Okay? So probably Wednesday we'll talk about that. You also are going to have to find something called the R squared. There we go. Sorry, you're going to have to find and interpret a value called R squared. Now that value can be found on the calculator already, but you don't know what it means yet. So we're going to, again, this will be on Wednesday. So on Wednesday, we're going to talk about R squared, and on Wednesday, we're going to talk about residual plots, most likely. Okay? So you'll have everything you need to do to turn it in on Friday. But what you don't want to do is wait until after class on Wednesday to start this, because you've had it now for almost a week already, right? So you really want to get, because it's a lot, and it's going to count a half test grade. So it's going to count quite a bit of points, okay? Because it's a lot of work. All right, so any questions on anything that's not highlighted that you should be able to do? Nicole?
It says that we'll have 8 separate rounds.
Yes, you're going to have 4 scatter plots and 4 residual plots.
Okay.
So total of 8. Yeah, the residual plot you haven't done yet. So right now you should be able to just create 4 plots for each. Oh, I'm sorry, 1 plot for each for a total of 4. A scatter plot's all you know right now. Okay? Any other questions about the non-highlighted stuff? Yes? Yeah, it's the y hat equation. Yep. It just stands for least squared regression line. It's just another way to say it. Yep. Any other questions? Now's your chance. Why is math so hard? This isn't hard yet. Okay. So let's talk about what a residual is. Okay, I'm going to turn this off just so we can see it in the back. We all know that when we graph a scatter plot, and by the way, some of your scatter plots that were turned in actually had lines connecting all of the points. Please don't do that. Okay? Scatter plot should just be that, a scatter of dots. And we're hoping that we can describe it as a positive, strong, linear relationship. Remember, we have our strength, direction, and form that we talk about when we talk about scatter plots. But we know that models aren't going to be perfect. Unless, the correlation's very rarely equal to positive or -1. There's going to be some kind of variation in the points. Some of the points are going to be above the line of best fit. Some of those points are going to be below the line of best fit. And we're going to estimate from the model, from the predicted value is called a residual. Okay? So what is a residual? The difference between the observed value and the predicted value. That is what a residual is. That is the definition of a residual. And I'm going to make sure that you look at that. Just write it a little bit so it's not in red. Y minus Y hat. Sometimes you'll see me write it as observed minus predicted. Okay? That is the residual. That is what a residual is. If you think about a scatter plot, okay, let me take that last point off so it doesn't look curved. And we take and we're going to go ahead and draw a line of best fit. What I mean is that the model, the equation, the y hat, the prediction line, the blue line that's drawn up there is just that. It's just a model. It's not perfect. There's going to be some variation. Some of the points are above that line. Some of the points are below that line. It's the vertical distance between the point and the line that is the residual. So I'm going to show you a picture here that really kind of, I'm going to try to make it a little bit bigger so we can see. But this picture really talks about what a residual is. I have a scatter plot of blue dots. This happens to be the Burger King data from last class where we talked about the protein versus the fat content on all the menu items. The red line is, in fact, the line of best fit, or the least squared regression line. But if you notice, we have this, this point here is the y value. It's the observed value. All of the blue dots are the observed values, where the red line is the predicted value. So if I'm trying to find a residual, the residual is simply going to be the distance from the observed, which is the blue dot, minus the predicted. So if you remember the formula for it's the observed minus the predicted. How do I find the observed values? What are they in the graph? Are they the red line or are they the blue dots? The blue dots. So the observed values are going to be given to me. In your scatter plot investigative task, the observed values are the y values that are in your data sets. So they are the given y values. Is the observed. Minus, how do I find the predicted values? I'm going to use, they're going to be the y values with using the line of best fit. So they are the y values that are found using your y hat equation. And those are going to be the residuals. Now we're going to practice finding the residuals in a minute so you can see what I mean. But from just kind of a visual perspective, do you agree that we can have, all of these are different kinds of residuals. This is going to be a residual. I can just kind of draw them all on here. Okay? So all the ones in blue are above the line. All the ones in yellow are below the line. You with me so far? Which ones would be positive values, the blue ones or the yellow ones? Remember, it's the observed minus the predicted. So all the ones in blue, the observed are the bigger values, and the predicted are the smaller. So when we have, is that going to be a positive value or a negative value? It's going to be a positive value. When I talk about the observed being below the line of best fit minus the predicted value, those are going to be negative residuals. So I'm going to have some positive values and some negative values. What the least squared regression line actually does is it minimizes those residual values. So that what it means is that when I add all of the residuals together, if I have some positives and some negatives, what should the sum of the residuals always come out to be, or close to? About 0. Okay? If this is the best prediction line, the sum of the residuals should be close to 0. I believe that is something that you will show on your scatter plot investigative task. I think one of the questions says, what is the sum of the residuals? You're going to find all of the individual residuals and show me what they add up to. Due to rounding, it might be like 0.002 or negative 0.005 or something, but it should be close to 0. Okay? So we know what they look like when they're positive. We know what they look like when they're negative. Let's actually practice finding some residuals to begin with, okay? So let's just take a data set. I'm going to just make one up. I'm just going to make one totally. Let me use one from, I don't want to use one from your homework, so I'll just make one up. It's fine. I'm just making this up, okay? So let's go ahead and just, let's graph this for a minute and see if we're going to estimate what the graph would look like. Oops, I should really go out. We should make it, we go out to 1. Okay? And we're going to go up to 9. We're just going to graph a scatter plot right now. Okay? So I'm going to actually do that. We're going to graph the 0.23. We're going to graph the 0.35, 36. We're going to graph the 0.47. We're going to graph the 0.59. Does the data look linear to you? What would we say? Let's describe the scatter plot. Let's do strength, direction, and form. What do you think? Positive. Relatively linear. That would be our form. And we don't really know about strength yet because we have to find a correlation. But I would say it's relatively strong. I mean, it looks like it's pretty okay. Can you go ahead and put these values in the calculator for me? Let's go ahead and do y1, y2. Pull up my calculator and I'll do that too. Oops, doesn't want to move. Come over here. There we go. So we're just going to go ahead and we're going to go to our stat. We're going to edit. We're going to clear out any values that are there, making sure you never delete, always clear. You can always go to clear list and it will do it for you as well. And we're going to put in our values. We're going to put in the 2, the 3, the 3, the 4, the 5. Remember, these are bivariate data sets, so we're never going to unpair them. We're never going to sort the list individually. Okay? And we're just going to create a little scatter plot. Do you remember how to do that? Go to stat plot. Make sure it's on. Looks like it is from list 1, list 2, and then we'll zoom stat. So it looks similar to the one that we have graphed. If I want to be able to find the residuals, I have to find the equation of the line of best fit. And you guys are going to do that with your equations and do it by hand, using your B1 formulas and your B0 formulas. For time's sake today, we're simply going to just find the equation using the calculator. So I'm just going to do that real quick. Remember that this is just a backup. So if we go to, trying to find stat. Is that stat? Thank you. Stat, calc, and we're going to go to option 8. And we're going to go ahead and find our values. What do you think about our correlation here? Is our correlation strong? 0.98, so the strength would be relatively strong because 0.98 is pretty strong. We have our y-intercept of negative 0.538, and we have our slope of about 1.92. So if I'm going to write an equation here, the equation I'm going to write is going to be, well, I want to have it both at the same time. So I'm going to have y hat equals negative 0.538 plus 1.923 x. So that is going to be our equation. Would you agree? And if we wanted to graph this right onto, we can go to y equals, and we can plug in our equation. I'm not sure why it's doing that. Okay, so I have negative 0.538 plus 1.923x. And we'll graph it right on there, and we should see the line of best fit coming right through our points on the calculator. Now, some people, when they did the scatter plot investigative task, wanted to be able to just take a screenshot of the calculator graphs. I am okay with that. So if you have a graph link on your calculator and you want to be able to plug it in and be able to just do a screenshot, you can do that if you know how to do that. Otherwise, by hand is fine. Are you noticing we have some positive and some negative residuals here? Do you recognize that this point above the line should have a positive residual? Any point below the line should have negative residuals. Let's go ahead and find the actual residuals because you're going to have to do this too. So to find the residuals, what I suggest we do, and I'm just going to erase this so we have some room. You're going to create a little chart where we're going to now find our y hat value, and then we're going to find the residuals. And this is kind of what I expect you to do on your scatter plot investigative task. We only have about 5 more minutes before I have to turn this recording off, so I need to get through it, okay? To find the y hat value, I'm going to take my equation. I'm actually going to make this a little bit bigger, only because it's going to take some time, or take some work to show. So this is our residual. So it's going to be, I'm going to take this value of x, and I'm going to plug it into the equation here. That's my predicted value. This is what I'm trying to find. I'm trying to find the predicted. If you remember, what we see is our observed, what's given to us. Those were the points on the scatter plot. The predicted value is going to be negative 0.538 plus 1.923 times 2. Again, I'm running out of a little bit of room, so I'm just going to make some more room here. And again, where did I get these values from? This 2 is because that's the 2 that's attached to the 3 in my point. And when I plug this into my calculator, I'm going to find a value . Go back down. Oh, goodness. So I'm going to go ahead and say negative 0.538 plus 1.923 times 2. And my observed value is 3.308. Are we okay with that? To find the actual residual, if you remember, it's your observed value minus your predicted value. So in our case, it's going to be 3 minus 3.308, or we're going to get negative 0.308. It's the observed value minus the predicted values. That's the very first residual. Now I'm going to find the second one. The second one, again, I'm using the predicted equation, and I'm going to be plugging in this time what number? 3. And when I plug in a 3, what do I get? If you don't know how to do second entry and just go back over and hit enter and put 3 in, I get 5.231. You should notice that this is also going to be the same value because it's the same predicted value. So I'm going to find the residuals by taking my observed minus my predicted, and I have a positive value now. My observed minus my predicted, and I have my values here. And we're going to continue on and so forth. Time-wise, I'm going to stop here because this does continue. But these are the residuals. There's some work involved in finding them. Okay? Notice that they're small. They're the vertical distances from my scatter plot. If we go back to my scatter plot, you will see, go back to my scatter plot, you will see that this first point should have a negative residual, and it did. Negative 0.308. It's below the line of best fit. The second point, 0.231, okay? And then we have 1.231, and so forth. Are there any questions? No, this is a negative value, by the way. Sorry, I just noticed that's negative. 5 minus, that's negative, right?
Wait, is it 1 point?
This was 1.231. This was negative 0.231. When I subtract this minus it, it's negative. And that makes sense here, because if you look at your graph, this one's negative, this one's positive. Okay, so when you're finding your individual residuals, check them with your graph. Did I get a negative value where I should have? Did I get a positive value where I should have? And then on the question where it says, what is the sum, you're going to simply add all these up. Are we okay with what I'm asking you to do? So right now, all you know is what a residual is and how to calculate it. Next class, we'll talk about how to make a plot of them and what that tells us. Okay? So your homework is going to be to continue to work on this scatter plot investigative task. You have a lot to be able to do right now, and the only thing you don't know how to do is make the plots. Good enough? Okay. Somewhere I have a recording. There we go.